This is 7.2.1. We'll discuss about binary matrix operations. Given matrix A and B, which are real matrices of dimension m rows and n columns. We first review the most common binary operations, which are additions of matrices and the commutative law associated with this. If A and B are real matrices of dimension m and m, then A plus B is the same as B plus A. Basically, it says that matrices that are of the appropriate dimensions can be added together and they commute. A plus B equals to B plus A. The other law is the associative law of addition. Basically, if we have three matrices, A plus B plus C first is the same as A plus B first, then plus C. That is, order does not matter in associative law. Here again, we have three matrices A, B, and C of appropriate dimension: m by n, n by p, p by r. That is, they could be multiplied together. Then it does not matter the order of multiplication. That is, A times B times C is the same as A times B first, then times C. Order does not matter as long as all the matrices size agree. The final size of A, B, C is m by r. That is, the final output of A times B times C, regardless of the order, is m times r. Now we also have the distributive law. That is, A multiplied by C plus D is the same as opening up the bracket, performing A times C plus A times D. That is, we can distribute the multiplication. The other example is A plus B first multiplied by C is the same as A times C first plus B times C. However, you must realize that A times B is definitely not equal to B times A, even when the size of the operation allows. Here we use the word in general, and of course sometimes you can find special matrices of A and B that commutative law of multiplication exists, but in general, these operations, even when the size allows, are not equal to each other. Some more binary operations. Here we are going to talk about scalar multiplication, product with a scalar. The scalar is C, and we can left multiply C times A or A times C, it doesn't matter. Basically, all the elements of A is multiplied by C. So the scalar multiplication is commutative. That is, C times A is equal to A times C. Also, if we have C multiplying by A times B, it's the same as C times A first multiplied by B. Or we perform A times B matrix multiplication first, then multiply by C. That is, the scalars have the commutative properties. This ends a quick review of binary matrix operation.